Hi everyone, welcome to G World of Academic Physics. Today we will discuss one of the application of electric field, that is force of interactions. How the questions will be framed. Let's consider a infinite rod having line charge density lambda 1. This is positively charged rod. And there will be a finite rod having line charge density is lambda 2 of length L, which is exactly at a distance A to this infinite rod of line charge density lambda 1. And the question will ask you, find the force of interaction between these two things, this finite and infinite rods. Before solving these questions, there will be some information that must be in the mind of the student. What is that? This is a infinite rod having line charge density is lambda 2. This is goes to infinity and this end goes to infinity. And what is the expression of electric field at point P at a distance d to this infinite rod of line charge density lambda? The expression is 2k lambda by d, and the direction is like this. This is the direction at this P point. The direction will be like this, 2k lambda by d. Exactly the same concept I will use here. When this kind of questions is given, I must consider a small element on this finite rod. I will consider a small element. This small element length is dx and charge on this small element is dq. I said the length is dx, charge is dq, and it is exactly at a distance x. If I want to redraw the same scenario, what I will draw, this is my infinitely line charge density, infinitely rod having line charge density lambda 1. Exactly at a distance x, there will be a small elementary charge sections. Charge is dq and length is dx. So I will write my expressions due to this infinite rod. The expression of force is nothing but the electric field of this infinite rod and the charge of these elementary sections. So expression of electric field I can write as dF because I am writing the expression for this small element. That's why I'll write as dF, and dF can be written as electric field due to this infinite rod, that is k 2k lambda upon x because distance is x and charge is dq. This is the expression of electric force, that is electric field of this line charge and the charge of dq, and 2k lambda, here lambda 1, I must introduce lambda 1 x, and dq can be written as what? Lambda 2 dx. dq, this small element, how much charge will be lies here? This is can be written as lambda 2 dx. This is 2k lambda 1 lambda 2, little arrange here, dx upon x. This is the force due to this infinite rod on this small element. If I'll go for net force, I must integrate and I'll get the net force expressions. And the net force will become like this. This is F net will become like this, 2k lambda 1 lambda 2. And what is the limit of integrations? If I will consider my element here, very small element here, the minimum limit will come a. If I will consider my limit, my small section element will be here, the limit will be a plus L. It means the minimum limit is a and the maximum limit is a plus L. If I will consider my element here, these sections here, the limit will be a, and if I will go to this x on my element, the limit will be a plus L. So it is very clear, fundamentally the limit is a to a plus L. And we all know the expression of dx by x is ln x, and I will put this limit a to a plus L. Little shifting these things, 2k lambda 1 lambda 2, this is ln a plus L minus log ln a. Yes. log A minus log B, the expression is log A by B. So I can write my net force directly. I can write this is as 2k lambda 1 lambda 2 ln A plus L by A. I hope this scenario is pretty clear to everyone. So this is what is the expression, 2k lambda 1 lambda 2 ln, this is 1 plus L by A. If someone want also putting the value of k, the value of k is 1 by 4 pi epsilon naught. So lambda 1 lambda 2 upon 4 pi epsilon naught, this is 2 ln 1 plus L by A. The expression is coming lambda 1 lambda 2 upon 2 pi epsilon naught ln 1 plus L by A. I hope the net force expression is clear to everyone. So let me discuss one more time for the student perspective. This is a finite rod having line charge density lambda 2. This is an infinite rod having line charge density lambda 1. The rod is exactly at a distance A. When this kind of question is given, I must consider a very small element. I consider this element, the element is dx, length is dx, charge is dq, and it is exactly at a distance x. So I'll write the electric field of this infinite line charge, and I will multiply the value of dq. I'll get the expression of force, because force expression is nothing but electric field into dq. So this is for an infinite rod having line charge density lambda 1 expression. This is dq, my charge, and dq can be written as lambda 2 dx. And doing the integration, putting the lower limit as a and the higher limit as a plus L, and solving this basic integrations, I will get the net force expression is lambda 1 lambda 2 pi epsilon naught ln 1 plus L by A. Let's do one more illustration for the student perspectives and things will be more clear. How the question has framed, this is one rod. You can say this is one rod. I will just want to how to draw the scenario. This is one rod. This is goes to infinity. This end it goes to infinity like this. Exactly at a distance A, exactly I will consider a distance A, there will be another rod, infinite rod, which is exactly passing like this. A student has to visualize these things. This is an infinite rod having line charge. I will consider this rod having line charge as lambda 1. How I am given a cross mark that indicates what? It is exactly, it goes like this. Inside it goes like infinitive, outside also goes to infinitive. There will be another, this is a rod, exactly this rod having line charge density lambda 2. This is also infinite rod which is exactly separated by distance A. Now the question will ask you find the force of interaction, and one student can easily predict this is one rod, this is one rod, and these two rods are mutually perpendicular. These two rods are mutually perpendicular. At a distance A there will be a separations. When this kind of questions is given and the question is framed, find the force of interaction. What will find? The force of interaction. So when this kind of questions is framed, I must think about a element. So what I will consider? I will consider one element is here. This element I can say exactly at distance x from this rod I will consider one element. So if this is my rod, this is an infinite rod, the electric field will be go like this. The electric field will be go like this, and it makes an angle theta. How many components of electric field will be generated? This is my electric field. There will be two components here. One is, if this is theta, this is theta, this is E cos theta, and this is E sin theta. And this small element I consider the charge is dq and length is of this small element. One can think this small element is dx. The length is dx. This is a small element. In this small element, from x to dx length, a small element I prefer. The charge is dq. And What is the direction of electric field? Electric field will be go like this. Two components in electric field. One is E cos theta, another one is E sin theta. Similar fashion, if I will consider one element here at a distance of x, and here the elementary length is dx and charge is dq, and I will draw the scenario, the electric field will be go like this, and this angle also theta. So with this angle also theta. So this is E, and this angle is, this one is E cos theta, and this one is E sin theta. There will be two components, there will be E sin theta. So if someone will carefully observe the symmetry, that E sin theta and E sin theta are equal in magnitude but in opposite directions, and the net electric field will be like this. This is E cos theta, another one is E cos theta. This will be the net electric field. This is the net electric field. It will be in E cos theta directions. So what is the expression of force? The expression of the force, one can think, due to small element, what is the expression of force? The force is net electric field is E cos theta, and charge is dq. This is E cos theta and charge is what? dq. So E cos theta is what? This is a, this is x. Can I say this distance is a square plus x square root over? Yes. And we know this is an infinite rod. This is an infinite rod. So what is the expression of infinite rod at distance a square plus x square? The expression is, I can write, that is 2k lambda 1 upon a square plus x square, because we know the expression of electric field due to an infinite rod, the expression is 2k lambda by d. So here 2k lambda 1, d is this distance, a square plus x square. And what is cos theta? Cos theta can be written as a upon a square plus x square root over, and dq can be written as, I want to be little better way I want to write, and dq can be written as lambda 2 dx. So let me arrange the things. This is 2k lambda 1 lambda 2, and this is into a, and this is dx upon a square plus x square. This is my df, the force due to small element, force on small element due to this infinite line charge having line charge density lambda 1. If I go for integrations, I will get my net force. I'll go for what? My net force. So what is the scale of integration says? This is 2k lambda 1 lambda 2 and dx by a square plus x square, and we'll think about the limit. Very carefully, if someone will think about, I can take the minimum here, I can take the element here, then goes here, then goes here. If I'll go in this line, the element is 0 to plus infinity. If I consider element in this line, this is 0 to minus infinity. So a student must be very aware, the limit should be minus infinity to plus infinity. What is the limit? Minus infinity to plus infinity. So 2k lambda 1 lambda 2 a, and what is the integration? Dx upon a square plus x square, direct formula I will use. This is 1 by a tan inverse x by a. This is the integration formula one can use, that is 1 by a tan inverse x by a. If you observe carefully, and the limit I will put minus infinity to plus infinity. Little arrange here. So 1 by a cancel, lambda 1 lambda 2, I can put the value of k is 1 by 4 pi epsilon naught, and 2 cancel, that will become as what? 2 pi epsilon naught, because I am putting the value of k. And little carefully, this is tan inverse x by a, and I will put the limit of what? Minus infinity to plus infinity. I hope the scenario is clear to everyone. Let me, this is lambda 1 lambda 2 upon 2 pi epsilon naught. This is tan inverse plus infinity minus tan inverse minus infinity. So what is the result is coming? Lambda 1 lambda 2 upon 2 pi epsilon naught. One student must know tan inverse plus infinity, it can giving rise to pi by 2 minus tan inverse minus infinity, it is giving rise to minus pi by 2. And if the result I will proceed, I will reach to the result, this is lambda 1 lambda 2 upon 2 pi epsilon naught into what? This is pi. Plus pi by 2 plus pi by 2, the answer is like this. So answer is coming lambda 1 lambda 2 upon 2 epsilon naught. I hope the scenario is clear to everyone. This is the expression of the net force. This is my final result, the expression of the net force. So let me, for the student perspective, one more time I want to make the scenario. This is one infinite rod. This is goes like this and this one goes like this. And this is an infinite rod having line charge is lambda 2 and here line charge is lambda 1. And these two rods are exactly perpendicular having a distance a. The question is asking find the force of interactions. If I will consider these things, I will consider a very small elementary section here. The elementary section of length dx exactly at a distance x. I consider a small element dx having charges dq and this is theta, this is theta. So if I will break, this is my electric field, two component E cos theta, E sin theta. Here also two components, that is E cos theta, E sin theta. Due to symmetry, I concluded one important thing, that the net electric field direction is like this, E cos theta. So due to net electric field is like this, the force also will be this directions. So I will write my E cos theta and I will write what? The charge. The charge is dq. So 2k lambda 1, this is a square plus s square. This is the expression of our electric field due to an infinite line charge, lambda infinite rod having line charge lambda 1, and this is cos theta value I put it here, and doing the simple integrations minus infinity to plus infinity, proceeding in the similar fashion, I reach the conclusion the expression is lambda 1 lambda 2 upon 2 pi epsilon naught. This is f. I hope this scenario has clear to everyone. Let me do one more application so the student will be more aware about the things. Question 3 based on force of interactions. How the questions will be framed. This is a ring. This is what? A ring having charge q is uniformly distributed and the radius of the ring is r. The radius of the ring, what I will say, r. This is one infinite rod. You can say this is one end goes to infinite rod having line charge is lambda is placed exactly at the center of the ring, and the question is asking how much force will experienced by this infinite rod, one end goes to infinite rod due to this charged ring q, uniformly charged ring q, or the question can be say like what is the force of interactions? What is the force of interactions? Force of interactions. Solving this question, a student must aware about what is the expression of electric field due to one end goes to infinite rod. If I will little recall these questions, a student must think about it very carefully. Suppose this is my rod, one end goes to infinity like this, having line charge is lambda, exactly P is a point. At this point, what is the expression of electric field? There will be two components of electric field, and if I will say this distance is d, the expression is k lambda by d, and this side the expression is k lambda by d. Yes, the expression will be k lambda by d, and this expression is what? K lambda by d, due to one end goes to infinite rod. Due to one end goes to infinite rod, one perpendicular component is like this, another one is parallel component will be like this. Can I use the same concept here? Yes, I can use the same concept here. If I look at this ring, due to infinite rod, exactly r distance, how many components of electric field? I just want to connect like this. So, two components of electric field, this is one component, there will be another component like this. Yes, this component, the expression of electric field is k lambda by r, because here the distance is r and here the distance was d. So here the distance is r, so that's why k lambda by r, and here also k lambda by r. Similar fashion, if I look at this end, the expression will be k lambda by r, and perpendicular component will be what? K lambda by r. This side the expression is k lambda by r, this side the expression is k lambda by r. And if you see very carefully in the symmetrical property, this is upward, this is downward, equal in magnitude. So these two components can cancel each other. And what is the expression is coming? The expression is the net electric field in this directions. The net electric field in this directions. And what is the net electric field direction? The net electric field is k lambda by r. Yes. And this is in what direction? In this direction, the net electric field is moving like this. Only parallel component is exist, no more perpendicular component. Because of symmetry, these things have been cancelled out. So expression of electric field due to this infinite rod we get. So if I'll write my force is nothing but electric field into charge. Charge of what? On the ring. So directly one student can write the expression is k lambda by r and the charge is q. So direct answer is k q lambda by r. This is the expression of force of interaction between this charge rod, force of interaction between this in one end infinite rod and charged ring having charge q is uniformly distributed on this ring. So what I did, one more time I want to clear to my student, I consider the electric field due to one end goes to infinity having two component, one is k lambda by r, another one is k lambda by r. If someone will look at the property of symmetry, these perpendicular components have cancelled. There will be only parallel component and the expression is k lambda by r like this. The expression is what? K lambda by r. If I will consider this angle is theta a little bit, one can be think also like this. K lambda by r, this is k lambda by r. And reaching this conclusion, we reach that this is the electric field into, I will multiply the charge, electric field of this, and multiplying this charge, I can say how much force is experienced by this ring due to this infinite one end rod having line charge is lambda. I will get the conclusion. If a student, this is the smart way and this is very helpful for the competitive approach. One student also in the other way can think, what the student will think, taking ring and making a small element on this infinite rod from x to dx, writing the electric field of the ring and multiplying the charge of the element dq, one can also solve and get the result exactly as kq lambda by r. I will suggest to the student, those are preparing for the competitive, they must look this kind of approach rather than other approach that cannot be, that will be more time taking. One more illustration I want to make for the student perspective that will be more helpful. What I have considered, I consider a ring, semicircular ring. This is my semicircular ring. Charge q is uniformly distributed on this semicircular ring. Having radius of this semicircular ring is r. This is the radius is r. Exactly from one infinite rod, exactly perpendicular to the plane of the ring. Exactly what? Perpendicular to the plane of the ring. Having line charge, this rod is lambda. This rod is infinitely large and having line charge is lambda. And this rod exactly perpendicular to the plane of the ring and passes exactly point O, you can say. The question will ask you find the force of interactions, or the question will ask you find the force, find the expression of force on this ring, semicircular ring due to this infinite line charge, having line charge density lambda. When this kind of questions are given, a student must think like this. I will consider a small element here. I will consider also a small element here. First think about this small element. From theta to d theta, I will consider a small element having charge dq and length is dx. This is very important concept. A student has to be think about it. A student has to be think about it. Let me redraw because this diagram is not clear for the student perspective. So this will be help you like this. I want to draw it in a better manner. This is exactly a rod is passing like this point, and it is goes to infinity. This is exactly passing and this is goes to infinity. This is my positive and the radius is r. What I will consider a small element here. This element having charge dq and length is dx. This length is what? Dx, and this element having charge is dq. Exactly I draw from theta to d theta. I will consider one small element having charge dq and length is dx. The expression of electric field will be go like this. The expression of electric field will be go like this. If you observe carefully, if this angle is theta, definitely this angle is theta. If this is E, so this is E cos theta, and this is perpendicular component, someone will be this is E sin theta. I hope this scenario is clear. Similar fashion, if I will go for the symmetry, from these sections, from theta to d theta, one element I will consider, the electric field will be go like this. And how many angles? This is theta and this is like this. So this is E cos theta and this is E sin theta. Due to symmetry, one student can predict this E sin theta component have cancelled each other, and the net electric field will be this direction, that is E net electric field will be E cos theta. And if you see the net electric field this direction, so the net force will be this direction. Can I write the expressions of the force small element? Can I write as E cos theta into dq? I hope this scenario is pretty clear to everyone. E, what is the expression of E? The expression of E is 2k lambda by r, because this is a infinite rod and the expression is 2k lambda by r and this is the length r. So 2k lambda by r cos theta, this is cos theta, dq can be written as charge per unit length. What is the length? The length is pi r into dx length. How much charge will be exist? This is 2k lambda by r cos theta. This is charge per unit length. Dx can be written as r d theta. Dx can be written as what? R d theta. Why it will be written as r d theta? If you observe carefully these sections, this is d theta, this is r, this is dx. So angle equals to arc upon radius. So d theta can be written as, dx can be written as r d theta. Cancelling out this r cancel, we reach the conclusion that 2k lambda upon pi r, this is cos theta d theta. And one q is also here. So this is what expression of the net, expression of the force on this small element. If I'll integrate and integrate here, I'll get the net force expressions. And what should be the limit? If I'll go carefully observe these sections, if I'll go in this section, if I'll proceed from here to here, I'll get 0. This angle is 0 to plus pi by 2. In this section, the angle is 0 to minus pi by 2. So it is very clear that limit is minus pi by 2 to plus pi by 2. I hope this picture is clear to all. Yes. So 2k lambda q upon pi r cos theta integrations is nothing but sin theta, and the limit is minus pi by 2 to plus pi by 2. So 2k lambda q upon pi r, 2k lambda q upon pi r sin theta, this is sin pi by 2 and this is minus sin pi by 2. And we all know, if you will solve these things, sin pi by 2 is 1, sin of minus theta is minus sin theta, minus 1 minus, it will be plus. So answer will be here 2. And here what is that? 2k lambda q upon r. So what is the final result is coming? The final result of f net I am writing here. Please look carefully, little here will be less space is available. So the expression is coming 4k lambda q, 4k lambda q upon r. If someone will want to substitute the value of k, what is the and pi is also here, so 1 pi is here, so there definitely pi is here. If someone will substitute the value of k, that is 4 lambda q, and the value of k is 1 by 4 pi epsilon naught, this is 4 pi epsilon naught r pi. So expression 4 cancel, and the result is coming lambda q upon pi square epsilon naught r. This is the desired result of the net force. I hope the scenario is clear to all. For my student, I just want to recall it one more time. What I have considered one ring, semicircular ring, and this is an infinite rod, and I am expecting that how much force of interactions. What I have done here, I am doing a small element from this small element from theta to d theta. I have considered one small element having charge dq and write the component of electric field. I concluded that there is only one component exists, that is E cos theta, and the net force will be this directions. Net force into charge, I'll get the expression of the force, and charge can be written as this dq amount of charge can be written as charge per unit length into this length, my elementary length, and elementary length this can be written as r d theta, and limit is very carefully. Here to here, this is 0 to pi by 2. Here to here, 0 to minus pi by 2. So my limit is minus pi by 2 plus pi by 2, and solving the basic integration, I concluded this result. I hope the scenario is pretty clear to everyone. Thank you everyone. Thank you for your watching. And these questions are very useful. Those are preparing for the competitives like JEE mains and other level of exams. Thank you for your watching. Thank you everyone.